let's find out the derivatives of the following functions. So if we have a function fx is equal to 4, what is the derivative of this function? We know that the derivative of this function is written as f stroke of x. Okay, it's also written as y, where y is equal to 4, and so we can also write like this, that is d dx of 4, and d dx of a constant is 0. Okay, so since 4 is a constant, d dx or the derivative of 4 with respect to x is 0. Okay, let's take another example. Fx is equal to half. So what is f dash x equal to? It is also equal to 0. Okay, so we have here, if fx is a constant b, then the derivative of that constant is 0 always. Okay, let's take another example. Fx is equal to root of 5. What is f dash x equal to? F dash x is equal to 0. Okay. Okay, now let's see this one. Fx is equal to x minus 2. What is f derivative of this function equal to? Derivative of x using this, applying this rule, is x to the power 1. So it will be 1 multiplied by x into 1 minus 1. And derivative of this is constant is 0. So x 1 minus 1 is 0. X to the power 1 is 1. So answer is 1. Okay, let's take another example. Fx is equal to x to the power 5. So f dash x is equal to, this is the power 5 multiplied by x multiplied by 5 minus 1, which is equal to 5x to the power 4. Applying this rule, power times the constant multiplied by x and decrease the power by 1. So let's see this one. Fx is equal to x plus 6. So the derivative of that function is, derivative of x is 1 and this is 0. So answer is 1. Let's take another example. Fx is equal to x to the power 2 plus L, where L is a constant. So L is a constant and 2 is a constant. So basically 2 plus L is a constant. Okay. So the derivative of the function fx is equal to, since this is a constant, we can write this constant 2 plus L times x times 2 plus L minus 1, applying the basic rule of differentiation. So this is 2 plus L, x to the power 2 plus L minus 1, 2 minus 1 is 1, so it is 1 plus L. So fx is equal to x to the power 4 plus 2x squared plus 4. So now since this is a sum of functions, we can apply this rule where it is a differentiation of the function of the terms separately. So this is 4x cubed plus 4x plus 0, which is equal to 4x cubed plus 4x. Okay. Let's take another example. Fx is equal to 1 upon x plus x squared plus 8. So 1 upon x is x to the power minus 1. X to the power minus 1, we can write it like this, plus x squared plus 8. Now, so f dash x is equal to what? This is minus 1 into x. Minus 1 into x is minus x. And minus 1, minus 1. Minus 1 minus 1 is minus 2 plus 2x. 2 multiplied by x, and 2 minus 1 is 1. So x to the power 1 is x plus 0. So answer is minus 1 upon x squared plus 2x. Okay. So these are some of the simple problems on differentiation. Okay. Let's see this one. Fx equal to x to the power minus 2 minus 3 to the power x minus 3 minus 4x to the power minus 4 plus 2. So this is equal to minus 2. Minus 2 into x. Minus 2 minus 1 is minus 3. Now minus 3 into minus 3 is, this becomes plus. So this becomes 9. X to the power minus 3 minus 1 is minus 4. This is also minus 4 into minus 4 becomes plus 16. And this is x to the power minus 4 minus 1 becomes minus 5 plus 0. Okay. So this is the answer. So we can just remove the 0. So the final answer will be this one. So let's see another one. Fx is equal to x squared plus 2x into 3x plus 1. So now since this is a product of two functions and we have a product rule here, we can apply the product rule here, or we can expand this expression into one function and do the derivation. So let's do it by the first one. So x squared into 3x is 3x cubed. X squared into 1 is x squared. 2x into 3x is 6x squared. Plus 2x into plus 1 is plus 2x. So this can be written as 3x cubed plus 7x squared plus 2x. So the derivative of that function f dash x is equal to 9x, 3 minus 1 is 2, 2 into 7 is 14x plus derivative of 2x is 2. Okay. If you apply the product rule, I just have to, let's do it by applying the product rule. So if I apply the product rule, this one, number 2, then it will be function remains as it is, x squared plus 2x into the differential of this one. So it is d dx of 3x plus 1 plus 3x plus 1, the second function, into the differential of the first function. Okay. So let's see this one. So it is x squared plus 2x, differential of 3x plus 1 is 3 plus 3x plus 1 into differential of 2x, x squared plus 2x is 2x plus 2. Right? Okay. So this becomes 3x squared plus 6x. Now we expand this one. So this is 6x squared plus 6x plus 2x is plus 8x, and we have last remaining is plus 2. So now we group all the terms. So this one becomes 9x squared, 6 and 8 is 14x plus 2. Did we get the same answer as before? Yes. Okay. But this is a slightly longer method than this one. So in this case, expanding first and then taking the differentiation is much easier than applying the product rule. So let's take another example. Fx is equal to x squared plus x plus 1 into x plus 1 by x. Okay. How are we going to do this? Shall we apply the product rule or shall we expand first? I think here also it's easier to expand first. So x squared into x is x cubed. X squared into 1 by x is x, because x squared and x, 1x cancels from this x. So now let's take the second term. X into x is x squared. X into 1 by x is plus 1. And the last one is 1 multiplied by x is x. And 1 multiplied by 1 by x is 1 by x. So let's group all the terms together. So this becomes x cubed plus x squared. There is only one term in x squared. I have 2 x's here. So it becomes 2x plus 1 by x plus 1. So now it's very easy to differentiate. So x cubed is 3x squared. This is 2 into x into 2 minus 1 is 1. Differential of 2x is 2. And differential of 1 by x is 1 by x squared. Now we must be very clear. This is x to the power minus 1. So minus 1 is minus x to the power minus 2. Minus 2 goes to the denominator x squared. And this is 0. Okay. So we remove the 0 from the final expression. And this becomes the answer. So let's see this one. Fx is equal to 2x plus 3 into x squared minus 1 into 3x cubed plus 2. Now this is a 3 terms are there. Again, we can apply the product rule for, we can take this function as one of the functions and this is the second function. And after we apply the product rule, again we can apply the differentiation for these two functions separately. Rather than do that is quite a lengthy way. It's better to again expand twice and find out the final differentiation. So let's do that. Let's multiply this and this together. So we get 2x into x squared is 2x cubed minus 2x plus 3 into x squared, that is 3x squared minus 3. Okay. I hope that's correct. 2x cubed minus 2x plus 3x. So yes. And this will be multiplied by 3x cubed plus 2. So let's now multiply these two together. So start from this one. We multiply 3x cubed by 2x cubed. That is 6x to the power 6. 3x cubed minus 2, that is 6x to the power 4 plus 9x to the power 3 into 2 is 5. Okay. And lastly we get 3 into 3 is 9x cubed. So this becomes a second term. And now we multiply 2. So let's write in the relevant space. So this becomes plus 4x cubed. Now 2 multiplied by minus 2x is minus 4x. 2 multiplied by 3x squared is 6x squared minus 6. So let's group all the terms together. 6, there is one term, and put them in the correct order of decreasing powers. So 9x5, 6x6 is there. Now 4, this is minus 6x4. There is only one term. Now cube, there are two terms. So minus 9x cubed plus 9 is minus 5x cubed. Now let's take the term in 6x squared. There is only one term in 6x squared. There is only one term in 4x and minus 6. So this is the final expression for fx. So f stroke x, or the differential of this function x, is now becomes very simple. 6 into 6 is 36 to the power 5. 5 nines is 45. X to the power 4. This becomes minus 24. 4 into 6 is 24. X to the power 3 minus 15 x squared plus 12x minus 4 minus 0. So finally we not write the 0. So this becomes the answer. Okay. Okay. So now let's see some questions on the quotient rule. This is called the quotient rule. And this is called the product rule, as we have done, as you know from the previous lectures. So this is x squared plus 5 upon 2x squared plus 1. So this is the first function, this is the numerator, and this is the denominator. So the quotient rule says the denominator, that means 2x squared plus 1 into the differential of the numerator. X squared plus 5, the differential is, derivative of x squared plus 5 is 2x plus 0. So it is 2x minus, sorry, I made a mistake here. It should be a minus here. Okay, it should be a minus here. Minus, so this will be, and then the numerator x squared plus 5 into the differential of the denominator. That means it is 4x upon the denominator squared. It's just a question of expanding and rearranging the term. So it's 2x and 2x is 4x cubed plus 2x minus. Now since this is a minus, you have to be very careful. So I'll put them in a bracket to be more alert on the changing of the signs. So first let me expand internally. So it is 4x cubed plus 4 5s is 20x upon 2x squared plus 1 whole square. So this becomes 4x cubed plus 2x. Now it's very easy to understand the signs. Minus into plus becomes minus 20x upon 2x squared plus 1 whole square. Okay. So we just have to, there's only one common terms. Okay, we have here, this cancels with this one, and plus 2x and minus is minus 18x upon 2x squared plus 1 whole square. Okay. So this is some problems on. Let's see one more problem which seems a little bit, but I think it's quite easy. 1 upon x to the power n plus 1 minus x squared. This is n. Okay, and x is not equal to 0. X is not equal to 0. So differential is, this is a power, so it will be 8 n to the power x n minus 1. Xn will go as to the top as x to the power minus n. So when you differentiate, it will be minus n x to the power n minus 1. So it will become n minus 1. And this is 0. And differential of minus is minus 2x. Okay. So we can just remove the 0 from the final expression and this becomes the answer. Okay. Thanks for watching till we meet in the next lecture.